Hello everyone. My name is Takuo Takarada. Please call me TT next time we meet on the road. I teach physics at a high school in Osaka, the second most populous area in Japan. By the way, have you ever intuited the ratio of planet size, mass, and revolution radius, or gravity? That is not really something you encounter in everyday life. I teach my students about these things in class, but they used to find it very hard to understand. So I came up with an experiment that lets you intuit the ratio of planet size, mass, and revolution radius, and universal gravitation. This experiment is an improvement of the uniform circular motion experiment. Today I'm going to talk about my experiment about Kepler's law of harmonies that you can do with your students. I hope you will enjoy my lecture. The left picture is Tycho Brahe. He was an astronomer who accurately and repeatedly measured the planets' positions for 40 years. The right picture is Johannes Kepler. He was a mathematically talented astronomer who tried to figure out the mechanism behind beautiful outer space. As fate would have it, they met in 1600. Tycho passed away 1 year later, but about 20 years down the road, Kepler derived the law of harmonies and scientifically proved the theory of heliocentrism, which today we take for granted. Kepler's law of harmonies goes like this. The square of the period of a star orbiting around the Sun and the cube of the long radius are proportional to each other because Earth, Mars, Jupiter, Saturn, and Halley's Comet orbit the Sun. He found that they have the same value. This is how you can experiment with Kepler's great majestic law in the classroom. This ball represents a planet. Spin it over your head. That's all. And it's so simple. This is the experimental equipment we use. It is a planet made of resin clay. From right to left, we have Mars, Earth, Venus, Mercury, and finally the hypothetical planet X. This is resin clay. The total of clay and paperclip is 100 grams. Shape it. Boil for 20 minutes on low heat. When it gets cold, it's done. Next, we have a weight. It corresponds with the universal gravitation that planets receive from the Sun. We also have a glass tube. Both ends are heat-treated for safety. If you put a string through it, you can make the planet move in a circular motion. We also have some fishing lines. It is used to connect the planet and the weight. And we have one last thing, stopwatch. It is used to measure the orbital period of a planet. The mass of the weight corresponding to universal gravitation used in this experiment was calculated using data from the planetary fact sheet. The basis was 100 grams for the Earth's mass, 0.45 meters for the orbital radius, and 270 grams weight for the universal gravitation. I wanted to try Jupiter too, but when I estimated its value using this ratio, they were too big, 86 kilograms for the mass and 2.3 meters for the radius of revolution, so I gave up. Let me explain the experiment. The members of a group will work together to carry out the experiment. On the fishing line, there is a black mark made with a marker just at the position of revolution radius. Let's practice for a while until the revolution settles over your head. If it's too fast, the part with the black mark will come out of the glass tube. If the revolution is too slow, it will be hidden in the glass tube. Don't touch the string or weight. When the revolution settles, measure the time it takes for 10 revolutions. The most important thing I want you to be careful in today's experiment is to keep your distance so that your planet doesn't hit the person next to you. If you are worried, wear a helmet and goggles. My student will show you an example. One of them will spin it over her head. The other will measure the time it takes for 10 revolutions. Very good. Well, I was planning to have everyone enjoy the experiment, but today I will do the experiment for you. Earth, Houston, here, Japan, here. Mass is 100 grams. Revolution radius is 0.45 meters. And universal gravitation is 270 grams weight. Three, two, one, stop. 1, 2, 3, 4, 5, 6, 7, 8, 9, stop. 7.78 seconds. Venus. Mass is 81.5 grams. Revolution radius is 0.325 meters, and universal gravitation is 421 grams weight. Two, one, stop. 1, 2, 3, 4, 5, 6, 7, 8, 9, stop. 5.50 seconds. Mercury, very small. Mass is 5.53 grams. Revolution radius is 0.174 meters. And universal gravitation is 99.1 grams weight. First, .90 seconds. If you revolve quickly, Mercury will move away from the Sun. And if you revolve slowly, Mercury will fall into the Sun. Mass 10.7 grams, and revolution radius is very long, 0.685 meters, and universal gravitation small, 12.5 grams weight. Stop. 1, 2, 3, 4, 5, 6, 7, 8, 9, stop. 40.53 seconds. Does conical movement affect the period? Conical motion does not affect the revolution period. This is the motion equation written for circular motion of the planet. Solving this gives us an angular velocity independent of theta. In this experiment, the angular velocity does not change with a magnitude of theta. In the revolution of Mars, the tension of string is small, but the frictional force is large. So string is hard to slip. Please experiment many times and get average. Yes, like Kepler. The last one, planet X. Mass is 50 grams. Revolution radius is 0.388 meters. And universal gravitation is 182 grams weight. Stop. 1, 2, 3, 4, 5, 6, 7, 8, 9, stop. 6.61 seconds. Now we are going to process the data. Then we will investigate the relationship between the square of the period and the cube of the revolution radius from the data. Let's enter the data of period. Mercury 0.190. Venus 0.550, Planet X 0.663, Earth 0.778, and Mars 1.453. Next, let's make this a scalar graph. You can see that it is proportional. The vertical axis shows the square of the period. The horizontal axis shows the cube of the radius. You can see that it is proportional. This is Mercury, Venus, Planet X, the Earth, Mars. Now you are just like Kepler. Kepler discovered his third law without using the law of universal gravitation. Also, when you get the planet models, you will be able to intuit the ratio of the size, mass, revolution radius, and universal gravitation of each planet. I hope you will encourage your students to experience Kepler's great achievements. These are some comments from my students. I was surprised at how quickly Mercury revolved. Mars was smaller than I expected. I can't believe that Kepler discovered the third law without using the law of universal gravitation. Thank you for your cooperation. I hope that humans will overcome the coronavirus. I hope to see you in Houston next year. Did you enjoy my experiment?